Physics Fundamentals Final Exam, Semester 1, 2019. Fay and Curtin. Please put your name on the blank here and the period that you have your science class here. Today's date goes here. Question 1. What does the digital box with lights A and B measure? A. Distance, B. Speed, C. Time, D. Acceleration. Question 2. What is the displacement of the flag on the energy car we use in lab? A. 0.01 meters, B. 0.10 meters, C. 1.00 meters, D. 10.00 meters. Match the term on the left with the definition on the right. Number 3, velocity. Number 4, distance. Number 5, time. And number 6, acceleration. Now you can either put numbers or draw lines. A, which one of these terms is how far? B, which one of these terms is how fast? C, which one of these terms is how fast velocity changes over time? Or D, how long something takes? Match the measurements on the left with the units on the right. 7. Velocity, known as v. 8. Distance, known as d. 9. Time, known as t. 10. Acceleration, known as a. 11. Mass, known as m. Now you can either put numbers or draw lines. A. Which one of these terms is meters per second squared, m divided by s to the square? B. Which one of these terms is meters per second, m/s? C. Which one of these terms is seconds, s's? D. Which one of these terms is meters, m's? E. Which one of these terms is kilograms, kgs? Number 12. When acceleration is 0, how is an object moving? A. At a constant velocity. B. Speeding up. C. Slowing down. Or D. Changing direction. Number 13. When acceleration is 0, an object is A. In equilibrium, B. Not in equilibrium. Question 14. What does it mean for something to move at a constant velocity? A. It is at rest. B. Its net force, F net, is 0 newtons. C. It is in equilibrium. D. All of the above. Question 15. Which FBD below shows an object in equilibrium? Is it A, this FBD, B, this FBD, C, this FBD, or D, this FBD? Question 16. Which graph below shows an object moving at a constant velocity? Is it A, this graph, B, this graph, or C, this graph? Answer questions 17 through 19 based on the data table below. So we have a data table, velocity of a toy car using one photo gate. And we have labels on top of the columns, position of photo gate from the dark mark in meters, these numbers. Displacement of the flag through the photo gate in meters, this number. Time through the photo gate in seconds, these numbers. Instantaneous velocity through photo gate in meters per second, these numbers. Question 17. What is the trend of the times through the photo gate? Do the times A mostly increase, B mostly decrease, or C mostly constant? Question 18 asks, what is the trend of the velocities through the photo gate? Do the velocities A mostly increase, B mostly decrease, C mostly constant? Question 19. Based on this data table, how is the car moving? A, it is speeding up, B, slowing down, C, constant velocity, or D, all of the above. Question 20. A force is a tool for converting units, B, final or initial velocity, C, velocity or an acceleration, D, push or a pull. Question 21. Forces are measured in A, newtons, capital N, B, kilograms, kgs, C, meters, m, or D, meters per second, m/s. We have a free body diagram here that goes to question 22. The above object is this one. Is it A, in equilibrium, or B, not in equilibrium? Question 23. Which graph below shows an object accelerating, also known as speeding up? Is it A, this graph, B, this graph, or C, this graph? Match the graph on the left with the description on the right. So graph 24 looks like this, graph 25 looks like this, and graph 26 looks like this. A, which one of these graphs shows positive acceleration? B, which one of these graphs shows negative acceleration? C, which one of these graphs shows zero acceleration? You can put the numbers here or draw lines to the graph. Match the definition on the left with the force on the right. Number 27. The force that opposes motion. 28. The force of a surface holding things up. 29. The force that pulls things down. Your choices are A. Gravity, F with a little g. B. Normal, F with a capital N. Or C. Friction, F with a little f. A toy truck that weighs 18 newtons is pulled to the right with a force of 16 newtons but does not move. Here's a free body diagram showing you that. Number 30. What type of friction is acting on the toy truck? Is it A. Static friction, F sub Fs, or B. Kinetic friction, F sub Fk? Number 31. What is the normal force, F sub n, acting on the toy truck? Is it A. 18 newtons, B. 2 newtons, C. 16 newtons, or D. 34 newtons? Number 32. What is the force of friction, F sub F, acting on the toy truck? Is it A. 18 newtons, B. 2 newtons, C. 16 newtons, or D. 34 newtons? Number 33. Mass is A. the force of gravity, F sub g, on an object, or B. the amount of stuff in an object. Number 34. Weight is A. the force of gravity, F sub g, on an object, B. the amount of stuff in an object. Use the data table below to answer the questions 35 and 36. You have a data table with an average force in newtons, which is this number. Number of marbles, which is this number, these numbers. Mass in kilograms, which are these numbers. And calculated acceleration in meters per second squared, which are these numbers. 35. Based on the data table above, this one, as mass increases, acceleration A. increases, B. decreases, or C. stays constant. Number 36. The relationship between mass and acceleration in this data table is it A. direct, B. inverse, C. neither or has no relationship? Use the data table below to answer the questions 37 and 38. In this data table, we have a force in newtons, which is these sets of numbers, the mass with one marble in kilogram, which is this number, and the acceleration in meters per second squared, which are these numbers. Number 37. Based on the data table above, this one, as force increases, acceleration A increases, B decreases, or C stays constant. Number 38 talks about this data table as well. The relationship between force and acceleration is A, direct, B, inverse, C, neither. It has no relationship. Number 39. When an object drops or falls on planet Earth, what is the initial velocity, or VI? A, 0 meters per second, B, 9.8 meters per second squared. 40. When an object drops or falls on planet Earth, what is the acceleration due to the gravity, also known as A sub g? A, 0 meters per second, B, 9.8 meters per second squared. Number 41. A bowling ball and a feather are dropped at the same time in this room. Which one lands first? A, the bowling ball, B, the feather, C, at the same time. Question 42. A bowling ball and a feather are dropped at the same time in a vacuum. In other words, there's no air resistance. Which lands first? A, the bowling ball, B, the feather, C, they land at the same time. 43. Which of the following has the most momentum? A 4,000 kilogram truck traveling at 30 meters per second. B, a 4,000 kilogram truck standing still. C, a 2 kilogram bird flying at 30 meters per second. D, a 2 kilogram bird sitting on a branch. Match the words on the left with the definitions on the right. Number 44, work. Number 45, power. Number 46, energy. Number 47, potential energy, also known as PE. Number 48, kinetic energy, also known as KE. 49, mechanical energy, also known as ME. Of these terms, which one matches A, stored energy, or the energy of height? B, work done over time. C, moving energy, or energy of velocity. D, the ability to do work. E, the total energy of a system. F, using force to displace something. Use the pictures below to answer the questions 50 through 53. A is a skateboarder here on the half pipe, and B is a skateboarder here on the half pipe. Number 50. Where is the skater's potential energy, known as PE, the highest? Number 51. Where is the skater's potential energy, PE, the lowest? Number 52. Where is the skater's kinetic energy, KE, the highest? Number 53. Where is the skater's kinetic energy, Ke, the lowest? Number 54. Simple machines. A. Trade force for distance. B. Make work easier. C. Include levers and pulleys. D. All of the above. Number 55. Which of the following is not a simple machine? A. A scissors. B. A keyboard. C. An elevator. D. A screw. Match the simple machine on the left to the description on the right. 56. A lever. 57. A ramp. And 58. A pulley. Which one of these terms is A triangle that trades force for distance? B. Uses ropes and wheels to increase force. Or C. A bar or stick that transfers force.